Hello, hello. Hey folks, are we good here? Let me know if I'm audible and let me just have one quick check with the AV here. Hello. And someone give me a thumbs up if things are good. Athar, Yashika. Hi, good evening. Just waiting for one confirmation if things are good. All right, great. Yeah, good evening. So welcome to one more session of your progressions where we're going to talk about miscellaneous series here. We'll have a couple of questions on AP, GP, some trickier ones. Then we'll get to know some questions that needs a little more idea to progress, and we'll see how to solve them. So this is going to be all solving, no theory. So we are pretty much done with the theory part of AP and GP. We're going to do some solving over here. So we'll take one question at a time. We'll attack them. I'll give you some 3-4 minutes to look into a question, and then we'll start solving it. Right. Let's get going. Have a bunch of questions to begin with. Have a look at this question, solve it. I'll give you like 3 minutes to understand and to see if you can put in some ideas to solve it, and then we'll start discussing it, right? Right. Uh, how many of you are struggling to progress with this question? Anyone who's like, what is even this? We talked about AP, we talked about GP, and is this an AP or a GP? How many of you are having that confusion now? Sounds a little tricky here, because when I look at the numerator, it seems to be like 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16. The numerator forms an AP. I look at the denominator, it says 5, 5 into 5 is 25, 25 into 5 is 125, 125 into 5 is 625, and so on. The denominator follows a GP. So should I account it for a AP or a GP? We call this to be an AGP series, arithmetic geometric progression, which means it is an AP in a format, it is a GP in a format. So questions like these are slightly lengthy to solve, but the idea is utterly easy. In fact, you would be surprised if I tell you that we have already learned the way to solve this question. The conceptual idea of solving this question, we've already done it. It's only a matter of time that we apply it and we get it done. Right. So let's do this. What I'm going to do is I'm going to call this, we need the sum of the series, right? Sum is equal to 4 by 5 plus 8 by 25 plus 12 by 125 plus 16 by 625, 20 by 3125 and so on. So what I'm going to do is I'm going to multiply this entire series by 1 by 5. I'm simply going to multiply this entire series by 1 by 5. I'll tell you why we are doing it by 1 by 5. When I do it by 1 by 5, 1/5 of the summation of n terms. So this will become 4 by 25. I can write it here. 1 by 5 into 4 by 5 is 4 by 25. Plus 1 by 5 into 8 by 25 would become 8 by 125. Plus 1 by 5 into 12 by 125 will become 12 by 625 and so on. So this is summation of n terms. This is 1/5 the summation of n terms. I know that this will be smaller than this because you are multiplying it by 1 by 5. Whatever total this is, this will be lesser than that. So what we are going to do is, I'm going to subtract this equation from here. Everything. When we do that, what will I get? Now, we'll keep this 4 by 5 as it is. 4 by 5 plus 8 by 5, 8 by 25 minus 4 by 25 will give me 4 by 25. 12 minus 8 will give you 4 by 125. 16 minus 12 will give you 4 by 625 and so on. But this will be what? 4/5 of, this will become 4/5 of Sn. Now I look at this, I realize this I can call it a GP. 4 by 5, 4 by 25, 4 by 125, 4 by 625, where A is equal to 4 by 5 and R is equal to 1 by 5. The denominator gets multiplied by 5 every time. So I'm going to call R is equal to 1 by 5. Now I know this is an infinitely decreasing GP. If you notice 4 by 5, 4 by 25, this is smaller. This is smaller than this. This is smaller than this. So every nth term here is going to be smaller than the previous term. So it is a decreasing GP. For an infinitely decreasing GP, we know that Sn is equal to A by 1 minus R. That will become 4 by 5 divided by 1 minus 1 by 5. Or you can write this as 4 by 5 by 4 by 5, which will become 1. So Sn is equal to 1, but we need 4/5 of Sn. So I will say 4/5 of Sn is equal to 1, or Sn is equal to 5 by 4, and that will be our answer. Lengthy one, but then the idea is pretty simple. You ensure that you multiply the series by a value so that we can make the AGP as a proper GP and then solve for it. A lot of times questions like this have popped up, especially in XAT. I've seen this question like 3-4 times across years. This is a standard template that they have used over the years. It's beautiful, but then you need to have the patience to sit and then write down everything, because it has to be a step-by-step thing. So hang on, sit in tight, get to know how it's done, and then apply. Right? Any doubts with this question? Anyone? Is there anyone who wants me to explain this again? I think the sum is pretty simple, pretty self-explanatory everywhere. Are we good here? We'll hop on to the next question, shall we? Great. Have a look at this question, solve it. I'll give you a couple of minutes and then we'll start solving it again. Right, we'll do this one now. A nice question. Consider the two progressions 5, 12, 19 dot 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 up to 798. 7, 17, 27 up to 627. Find the sum of all the common terms of the two progressions. 5, 12, 17, 700. So it has to be 698. This cannot be 798. It has to be of the form. Not a big deal. Now the question is, find the sum of all the common terms of the two progressions. I have to pick all the common terms from here and then I have to extract them, make a series out of it and then find the sum of that progression. The first question, will that be a progression in the first place? Let's have a look at it. Now when I look at 5, 12, 19 and so on, all the numbers in this format, I can think about it as 7n minus 2. Can we say that 7n minus 2? Put n equal to 1, 7 minus 2, 5. Put n equal to 2, 14 minus 2, 12. Put n equal to 3, 21 minus 2, 19. All of them work. When I look at this, 7, 17, 27, dot 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 and so on, I can think about all of them as 10 minus 3, 20 minus 3, 30 minus 3, or I can write this as 10m minus 3. Right? Now I have to pick a term where both of them are equal, or I can say 7n minus 2 is equal to 10m minus 3. So this goes here, this comes over here. 10m minus 7n is equal to 1. I'm bringing this over here and taking this over here. 10m minus 7n is equal to 1. Some multiple of 10 and then there is some multiple of n, 7. The difference between them is 1. I know that all the multiples of 10 ends in 0. So 7n has to end in 9 so that the difference is 1. So I can think about this as 49 and think about this as 50. That's the first place that it happens. So n is equal to 7. Here this will be m equal to 5. So I'm going to put it over here. If I put n is equal to 7, that will be 49 minus 2, that is 47. 50 minus 3, 47. Both of them, the first common term will be 47. That's how you pick your first number. You equate them and then you look for a multiple where it works and then you plug it in and you get it. 49 is the first number. But I need to know where will that number again meet. Now from 47, if I note there is a 47 here, that will keep going jumping by plus 7, plus 7, plus 7, plus 7, plus 7. This will keep jumping by plus 10, plus 10, plus 10, plus 10. So I have to keep adding 7, 7, 7. I have to keep adding 10, 10, 10. And the total has to be equal to come to another place. Or I can say, if I can add 70 here, and if I can add another 70 here, I'll go to 117. And that will be the next common term. How do I know 70? LCM of 10 and 7. When it meets at 47, the next place where it will meet is the LCM of the common differences. The common difference between these two series, for this is 7 and for this is 10. So 7 times 10, 10 times 7, they will go again meet in the same number, which is 117. So the next one will be 117, 187, dot, 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 and so on. But I cannot go all the way. I'm noticing it that I have to stop somewhere at 627 or 698. Obviously, it has to be 627. This is the smaller number. You cannot go beyond 627 now, because this series goes to only 627. If that's the case, I know my A is equal to 47 and then my D is equal to 70. A plus n minus 1 into D is less than 627. You can solve it using an equation, or I am thinking about this as 47. So I can go to 470 until 470 will work. Oh, 47, 70, 70, 70. Not 470, sorry. We can go till 560, because in this series, any Tn is of the form 70n plus 47. All the terms in the series happen to be of the form 70n plus 47. I'm thinking which multiple of 70 and 47 will go. I add one more 47, I go to 607. This is 70 into 8 and then plus 47. So I notice that the last number that I can go to is 607. This has to be intuition, or this has to be form like. There's no other way you can do it. I figured out my last number is 607 then. I start with 47, take it 70, 70, 70, increase it by 70 every time, and then I end up with the last number to be 607. I can call this to be an AP now. The sum of this AP, what will it be? 47, 117, 187 up to 607. Right. So how many terms will be there? This is the 8th term and there's a 47 sitting here. So n is equal to 9. Right. Or we can do it 607 minus 47 divided by 70 plus 1. This is 560 by 70 plus 1. 8 plus 1, n is equal to 9. The number of terms in the series will be 9. So I have the value of 9, I have the value of n, I have the value of a, I have the value of d. I can plug it in, I can do it. Or sum of the series is equal to n by 2 into first term plus last term. First term plus last term by 2 is average into n is sum. Yeah, done. So what will this give me? 9 by 2 into, this will become 654. 9 by 2, I can cancel this as 327. So 9 into 327 will be 2700, 180, 63, 349, 2943, and that will be our answer. Clear? Lengthy one, once again, lengthy one. It's not that easy every time. It's not easy to pick a pattern. It takes time. This class is all about picking patterns. You look at a question, you look at what pattern it follows, and then you apply that. It's not that easy to get into the groove and then straight away say, oh, this is of this format. It doesn't happen in a go. So spend time, look at the numbers, see if you can crack a pattern, and then look for it. Right? Any doubts? Any questions? We'll hop on to the next question now, shall we? Go for this. Again, it's a pattern sitting here. You need to pick the pattern. Have a go at it, and I'll show you how it's done. Again, a question that sheerly works on the pattern recognition. It's important that we look at a number, a set of numbers, and then we think about what is a standard pattern that we can write. So this question, when I look at it, I notice that it says 9 into 13. It has to be then 9 into 13, then 13 into 17, 17 into 21, and so on. Right, that's how it is supposed to be then. I'm looking first, the first recognition I'm finding, okay, how can I write it? I can think about this as 11 minus 2 into 11 plus 2. 15 minus 2 into 15 plus 2. And then so on. This will become 87 minus 2 and then 87 plus 2. So again from here I can write this as 11 square minus 2 square plus 15 square minus 2 square plus next one will be 17 square minus 2 square and so on until 87 square minus 2 square, and then 11, 15, 17 dot 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 dot. We'll have to look for a pattern for that, and then we'll have to say, okay, how can I look at 11, 15 and so on and on and on. That part is one way. Or you can simply break them down in from the word go. I want to write them in some quadratic form or in some equational form where I can substitute the variable as 1 from the beginning. What do I mean by that? You can think about this as, I want to bring in one standard format and then replicate it to all the variables here, all the values here. I can think about 9 into 13 as 4 plus 5 and then 4 plus 9. Right? 13 into 17 will become, you can write 13 as 4 plus 9, but what will be 17? These are 4 more, right? 9 to 13 is 4 more, 13 to 17 is 4 more. I can write this as 8 plus 5, 8 plus 7. So the next one has to be 12 plus 5, 12 plus 7. Or this I can write it as 4 into 1 plus 5 into 4 into 1 plus 9. This can be written as 4 into 2 plus 5, 4 into 2 plus 9. This can be written as 4 into 3 plus 5, 4 into 3 plus 9. Or any Tn in the series, I can write it as 4n plus 5 into 4n plus 9. Can we agree on that? Where n starts from 1. You can say n equal to 1, 9 into 4, 13. N equal to 2, 13 into 17. N equal to 3, you can do all of that. So what will be 85 into 89? N equal to 20. 4 into 20 is 80 plus 5, 85. 80 plus 9, 89. Right? Nice and easy. All I have to do is now Sn is equal to summation of n equal to 1 to 20 of 4n plus 5 into 4n plus 9. Right? Get this? We are through. Now it's a matter of doing the math, which can slightly be painful because you have to deal with a lot of numbers, multiplication and stuff, and solid math, nothing can be done here. So I'm going to expand this. So this will become 16n square plus 36, 20, 56n plus 45. So this will become summation of n equal to 1 to 20 of 16n square plus 56n plus 45. Or from here we can take it to 16, I can take it out common. Summation of n equal to 1 to 20 of n square. Because 16 is a constant, you don't have to do summation for that. Take it out, do the summation of n square. Plus 56, take it out, summation of n equal to 1 to 20 of n. And then plus summation of n equal to 1 to 20 of 45. So this will become 20 times 45. That's all. Right. So straight away be 20 times 45 because we'll have to add 45 20 times. That's all. Nothing fancy about it. So let's do this. This will become 16 into n value is 20. So that will become 20 into 21 into 41. N into n plus 1 into 2n plus 1. divided by 6 plus 56 into n into n plus 1 divided by 2 plus this will be 20 into 45. So let's do the math here. This will be 7, this will be 2, this will be 10. Can someone pull out a calculator and do the math for me here? This will be 10. This will be 900. This is 210 into 56. Can someone do the math? Looking at the calculator here. Into 10 into 45920. 210 into 56. Yes. 45920. This is, I got this as 12,660. And this will become 900. Can someone add these three? You're getting 58580. And that's your answer. Anyone? Yashika is saying repeat. Which part do you want me to repeat, Yashika? Tell me which part. This one's plainly painful. It's not a challenging question. It's simply tough because of the fact it's lengthy. So if I get a value, like for example, if I say summation of n, we say n into n plus 1 by 2. Summation of n square is n into n plus 1 into 2n plus 1 divided by 6. Summation of n cube is n into n plus 1 by 2 the whole square. These are three formulas that you need to know. Now I had this equation of 16n square, 56n plus 45. I'm splitting it. So for every value of 1, 2, 3, 4, I have to add them all. So what I am doing is I am splitting them as n square summation, n summation and the constant summation separately. And all of that has to run from 1 to 20. When you do that, you will get the answer. Clear, Yashika? Still not clear? Let me know. Clear? Simple? It's challenging. Again, as an idea it is simple. As a solving perspective, it is lengthy. It can drain you out. If you happen to be in the last 4 or 5 minutes and then you can get your hands on one question, this can probably drain your energy. You would feel like maybe I would solve some other question. It is not my go-to question because there's too much calculations and the chances of making an error is also slightly high. So I'll keep this for my review. I know I will do this. I know I can do this, but I'll not do this on my first go. That's all. Clear? We'll jump to the next one then. So same type of question, have a go at it. We'll see. So we look at this question. It says find the sum of the 8th to 13th term, both inclusive of the series 4 into 5, 10 into 6, 16 into 7 and so on. Same question, same idea, but they are not giving us all the way to from 1 to 13. They are asking from 8th term to 13th term. So there isn't a definitive formula to find a middle part of a series. When you are looking at a summation, we start from n equal to 1 to n. You cannot do it from midway, from 8th term, 13th term. Do we have a formula? We don't do it. So what we do is, we do summation of n equal to 1 to 13 and subtract summation of n equal to 1 to 7 from this. From the sum of 13 terms, we remove the sum of the first 7 terms. It will give us sum of the remaining terms. That's all. Also, this is an additional step to this question. For the rest of the part remains the same. Pick the pattern, find the equation connecting to it, find the standard general term of writing a term in the series, and then we are through. So what I'm thinking is, I look at 4 here, 10 here, 16 here and so on, 5, 6, 7. So this term here is increasing by 1, 1, 1, 1, 1. This term here is increasing by, this term here is increasing by 6, 6, 6. So I can think about this as, okay, this is a multiple of 6 and then something done to it. How can I write that? I'm looking at 4. I can think about that as a multiple of 6 and 2 less than that. Or I can write this part as 6 minus 2. This 10 can be written as 12 minus 2. The 16 can be written as 18 minus 2. Or this will become 6 into 1 minus 2, 6 into 2 minus 2, 6 into 3 minus 2. So that means my Tn will be 6n minus 2. That's fixed. The first part of the series I can write it as 6n minus 2. That is sure. But how can I write 5? Where n is 1, I need 5. I can think about that as n plus 4. Right? So this will become 1 plus 4, 2 plus 4, 3 plus 4 and so on. Or the generic term will be 6n minus 2 into n plus 4. Picking the pattern, it's not that easy. You can come around and then think about this. There's a multiple of 5, there's a multiple of 10. Maybe you will choose the wrong numbers to look for a pattern. How can I teach you how to pick a pattern? It comes out of your ability to look at numbers. Most of the times you will get some easy patterns to pick. So don't worry about what if it is complicated. If it is complicated, feel free to dump it and move on to the next question. Don't dwell over it. Some patterns are hard to recognize. Some patterns fall in place straight away. These are examples that are moderately difficult. It's not that tough. So hang on to think about it. And then the moment you pick the pattern, if you can write it in an expression format, we fly from there. Right? Now shall we do this? So I'm going to expand this. So Tn will be 6n square plus 24 minus 2 plus 22n minus 8. So what I want to do is summation of n equal to 1 to 13 of 6n square plus 22n minus 8. From here, I'm going to subtract summation of n equal to 1 to 7 of 6n square plus 22n minus 8. From sum of 13 terms, I'm subtracting sum of 7 terms, so that I'll get 8, 9, 10, 11, 12, 13. That's all. This part we have already done. So let's do it again to this question now. So first case is n equal to 13. Second case is n equal to 7. 6n square plus 22n minus 8. This is what I need to work for. So I'll take out 6 common. 6 into 13 into 14 into 27 by 6. Summation of n square into 6 plus 22, take it out common, 13 into 14 by 2. Summation of n terms minus 13 times 8. This will be one part. We will be subtracting 6 into summation of 7 into 8 into 15 by 6 plus 22 times of 7 into 8 by 2 minus 8 times of 7. So we need to sit and do this math. Feel free to help me out with the calculation. Let's see. The 6 and 6 gets cancelled. This 12 and this gets 7. This 6 and 6 gets cancelled. This is 4. Have it as it is. 13 into 14 is 182. This is 182 into 27 plus 22 into 91 minus 180, 24, 114 minus 56 into 15 is 840. That's easy. Plus 28 into 22 is 25 square minus 3 square, 616 minus 56. Just help me out with the math. Let me know if I'm making a mistake. I'm hopefully right here. 182 into 27. What is 192 82 into 27? Let me quickly check that. 182 into 27 is 4914 plus 22 into 19 is 418 minus 114 minus 114 plus 4914. This is 5218 4914 plus 418 minus 114. I'm getting 5218 here. Am I making a mistake? 13 into okay. Here this will be 840 plus 616 minus 56. This is minus 1400. 22 into 91. 22 into 91. Oh, this is 2002. My bad. 2002 minus 114. So 4914 plus 2002 minus 114 is 56082. Am I getting 6082? Is this? Is this 6082? Just second. Tell me 4914 2002 is this is 619 6916 114 208. Are we getting 6802? Yes. And what about this over here? 840 plus 616. 840 plus 616 minus 28 into 22 is 616. Correct. Are we getting 1400 here? Is the math correct here? This is 56 into 15. That's 840. And then 22 into 28. 11 into 56. 616. Are we getting 1400? Just checking every value here. Minus 1400. So this will become 5402. I'm just verifying every part here. Let me know if there is a math error. Are we getting this 5402? I hope 5402 is right. I'm just verifying it one more time. I'm just ensuring that we don't make any mistakes. 1366 gets cancelled. 182 into 27, 22 into 21 minus 114. 5402 is our answer. Right? We just have to be a little more cautious. Sometimes we make mistakes. And questions that go this lengthy, you have to be a little more cautious. Recheck it to ensure that we are not making any mistakes. There will be a gut feeling that will tell you, okay, verify it one more time. I all of a sudden got that gut feeling, and then I wanted to check it out once again, and here we are. Right? I think this was pretty good. Nice, neat question. We'll jump to the next one then. Go for this. Nice question. Hop on, do this. Athar, thank you for putting everything in this equation here. I think there is a small slip. The answers are good. 13 into 8. That's 104. Thank you for putting everything over there. I was looking into the chart in the meanwhile. 13 into 8. 10 into 8 is 80 plus 24 is 104, not 114. So all you have to do is slightly offset everything. Everything increases by 12 basically, 10, that's all. So it's 8, 1, 2, this is 104. So the answer is 5412. I was getting a slight feeling that was some issue, but I was looking into it the meanwhile, and then I noticed that you had everything. I was doing all the intricate math here. That's 5412, 5402. I told you, right? Sometimes in a slip, everything fell right. Everything. This one mistake that you do will cost you. If it is a theta, that's fine. At least you won't lose another 1 mark for it. But then all this way, only to lose it by a small margin, hurts. So ensure that we do the math. I'll also ensure I'll also get it right. Now I wrote it 114. In a haste, I wrote 114 and then we did the math. I realized something was offsetting. I was looking into the chart here and then I noticed 13 into 8 and below that I saw 114. I was like, okay, 13 into 8 is 104. Right? This is a nice question, but agonizingly painful to sit and do. This question is beautiful. I can do this question in two formats. I'll show you both formats. I'll show you one conventional format also give you the logic behind questions like this. In case you didn't know, let's do it. The sum of the first three terms of a GP is 14 and the sum of the next three terms is 118, 112. Find the sum of the first 15 terms of the GP. So sum of the first three terms I can write it as A into 1 plus R square, right? AR square. That is equal to 14. Next three terms will be A into R cube plus R power 4 plus R power 5. Right? But I can also take out R cube out common. So this will become, instead of writing R cube, R power 4 and R power 5, we can write this as AR cube into 1 plus R square. That will be 112. Right? Instead of taking A common, I am taking AR cube common. Now I can divide both these equations. 1 plus R square gets cancelled. A gets cancelled. 1 by R cube. I am noticing this gets divided. Beautifully gets divided 8 times. Right? 14, 8 into 10 is 80 plus 32, 118. This is 1 by 8. 1 by R cube is 1 by 8. R cube is 8. R is equal to 2. So plug in R equal to 2 here. So you will get A into 1 plus 2 plus 4 is equal to 14. 7A is equal to 14. A is equal to 2. So I have A is equal to 2. I have R is equal to 2. I need sum of 15 terms in the AP. Let's do this. So S15 is equal to A into R power n minus 1 by R minus 1. Why this formula? R is 2, this is greater than 1. So this will be the formula to be used. So substitute your values, you will get 2 into 2 power 15 minus 1 divided by 2 minus 1. 2 power 15. What is 2 power 15? 32 into 32 into 32. 32 into 32 is 1296. I'm going to do 1296. Sorry, 1024 into 32. 32768. This will become 2 into 32768 minus 1. So this will be 2 into 32767. So this will become 65534, because I know 32768 into 2 is 65536. You know that value because it's 256 square. I'm aware of that. So this will be 65534 and that's our answer. This is a conventional way of applying step by step, solving for A and R and then solving it, which will seem easy. But I'll show you one more way which will be a lot more easier to solve provided you know the logic. So let's do I'll show you the logic first. I'll give you an example and then we'll take it from there. I'll show you this. Let's say I'll take a GP called 1, 2, 4, 8, 16, 32, 64, 128, 256 and then 512, 1024. I've written all the way from 2 power 0 to 2 power 10. Now, interestingly, very interestingly, check this out. Pair them into 2. Club them into 2, 2 each. And add them. What is 1 plus 2? 3. 4 plus 8? 12. 16 plus 32? 48. 64 plus 128 will be 192. 256 plus 512 will become 700. 768. Right? We don't have 1024 and 2048 we add. Notice this. Do you see anything here? 3, 12, 48, 192, 768. Do you see any connection here? Do you see a pattern here? If you look closely, I added 2 terms, every 2 terms in the GP. I write them down. I realize that is also a GP, right? That also becomes a GP, correct? Do you notice that? Does it happen only for 2 terms? No. Let's do it for 3 terms now. 1, 2, 4 is 7. 8, 16, 32 is 56. 64, 128, 256. You add all 3 of them, you will get 448. If you notice, this is also GP. This one has a common ratio of 4. This one has a common ratio of 8. Take 4 at a time, you will create a GP with a common ratio of 60. So if you group them into n terms in a GP, that forms a GP. Now instead of worrying about what the series is, what is my A value, what is my R value, I'll simply say, hey, first 3 terms is 14. Sum of the first 3 terms is 14. Sum of the next 3 terms is going to be 112. Or I will say, I can create a GP of 5 terms, because 15 terms, it will be 3, 3, 3, 3, 3. Or I will say my A is equal to 14 and then my R is equal to 8, sum of 5 terms. Now the question is framed in a way that you don't necessarily have to find A and R. If the question says find the sum of 14 terms, I wouldn't do this. I cannot use this formula, I cannot use this logic, because I get 3 terms, I cannot make 14 terms, but I get 3 terms, I can make 15 terms, 5 times. So sum of 5 terms, A is equal to 14, R is equal to 8 and N is equal to 5. I can use this instead of sitting and finding what A and R are. So Sn is equal to 14 into 8 power 5 minus 1 divided by 8 minus 1, or 14 into what is 8 power 5, which is again 2 to the power 15. That will be 32,768 minus 1 divided by 7. Cancel it. 655. And here we have your answer. Clear? Instead of finding what A is and what R is and then finding sum of 15 terms, I'm saying A is 14, R is 8, and I'm finding sum of 5 terms. They both happen to be same. It all matters where do you look the question from. That's all, right? Any doubts? Any questions to this now? Are we good? Can we jump on to the next question? We have one final question to go for. We'll do this and then we are good. Beautiful question. Go for it. Right. We'll do this one final step. Now look at this question. The ratio of sum of the first 25 terms to the sum of the next 50 terms of an AP is 3:7. Find the ratio of the 13th term to the 38th term of the same AP. Once again, the same conventional way would be used. The same conventional way, you find the sum of the first 25 terms, you write it down. Sum of the next 50 terms, can you do it? No, you cannot. You have to find sum of all 75 terms, remove the first 25 terms sum, and that will be what? You write it as, okay, this is going to be sum of the next 50 terms. It's a classic lengthy way of doing it. The textbook way of solving this question is slightly uneasy. But then if you understand what AP is, what sum is, where does the sum lie, if you get to know all these ideas, you're completely through. So what I'm going to write here is, I want to think about this entire aspect as first term A1 to A25. Sum of all of this, I'm going to call it 3x. Right? I can write it this way. Now, from A26 to A75, this is 7x. Now, can I say sum of all the 75 terms is 10x? Can I say that 1 to 25 is 3x, 26 to 75 is 7x. I'm simply saying 1 to 75 is going to be 10x. That's all. Can I say this? Shall we? It resolves my problem by a fair margin now. Now, they need the ratio of 13 term to 38 term. So, we'll write a ratio. Now, I want to know how do I write sum of the first 25 terms? What is the most convenient way to write sum of the first 25 terms? There are 25 terms in an AP. Forget about this question. Or let's say there are 7 terms in an AP. How do you find the sum? What is the easiest thing to do? There are 7 terms. Think about A, B, C, D, E, F, G. 7 terms in an AP. How do you find the sum of this? Rather than saying A plus B plus C plus D plus E plus F plus G, what is the easiest way to do this? Seven into D. Why? The average of an AP is always the middle term, and sum of a series will always be average into number of terms. The average is D. Sum of the 7 terms is 7 into D. That's all. Right? In that case, what is the sum of A1 to A25? A1 to A25 sum, and then A1 to A75 sum. A1 to A75. What is the easiest way to write sum of the first 25 terms? Can I say that will be the middle term into 25? Can we say that it's the middle term into 25 terms in it? Or I can say that will be 25 times A13. Can we say that it's 25 times your middle term? What is the middle term of 25 terms? Sitting right in the middle, that is 13. There are 12 terms after that. There are 12 terms before that. 13 is sitting dead center. Right? We got this. Now, what is the sum of 75 terms? What is the easiest way to write sum of 75 terms? Once again, plot the middle term. Where is the middle term of 75 terms? Sitting right at 38. Or I can write this as 75 times of A38. And this ratio I can write it as 3 by 10. Sum of the first 25 terms is 3x. Sum of the first 75 terms is 10x. I'm writing it as 3 by 10. right? Or I can say 75, this gets cancelled 3 times. A13 by A38 is equal to 9 by 10. And that's exactly what the question is also asking. The ratio of 13th term to 38th term is what it is asking, which is 9:10. That's all. Now, in case if the question had what is the ratio of 20th to 23rd term, something like that, write A13 and A38 format. A plus 12D, A plus 37D equal to this ratio, cross multiply, write A in terms of D. That's a separate step. But most questions in this format are built in this format to make you understand, hey, there is a funda that you can apply here that will resolve your problem by 4 steps. If not, you'll have to do it the conventional way, which is more painful, right? Simple idea. This is a question I would happily pick. This is not a question that will take 4 minutes in my head. In my head, this is a solid 1.5 minute question if you know how to approach it. It's a 2-step thing. All of this is for you to understand. My only step is here. I'll straight away go here and then solve for it. Clear? Any doubts? Simple funda. Nice question to work with. So solve it. Get a gist of it. Practice all these questions. Get the DPP, see, solve the solutions, get comfortable around it. That's important. Any questions, folks? Any doubts? Right. We'll wind up here. A quick update. In case if you are already a part of the Telegram group, if you are a part of the Telegram group for MBA Wallah English, please continue to be there. If you happen to be in the Telegram group that you were already there for mine, dump that, scan this QR code, join that. So there's a new channel. The previous one was a place where you couldn't drop messages, so we had to remove it and create a new one. We have created a new channel. In case if you haven't joined it yet, scan this, jump over there, where we'll have a lot of discussions. Right? Any doubts, folks? All right, then that's it for the day. It was nice catching up with you folks again after quite some time. Hopefully, we'll have some other classes to learn some of the basic concepts that will help you out better in your preparation. We are done for the day then. Thank you. Athar, if you are a part of the old channel for my channel, the Bhaskar Sir Cat, if you are a part of a channel that you are already there, I want to know there's a new one. That one will not exist anymore. Both channels. If you happen to be a part of this channel, fine. Join this as well. Clear? I hope I made it clear. The old one that you were there was there, but that will go off because that was not a place. The students couldn't drop messages, but it was more of a subscriber format channel. But this channel is where you can also post your doubts, messages, questions, and everything. Clear? All right, folks. It was nice catching up with you again. We'll see you in the next class. Have a great week ahead. Thank you.